So class, today we're going to talk about one-step equations. And I know that word may sound a little foreign to you and you may not have done it before, but we have already done things like one-step equations. Like today, just doing your do now, I had you solve for the following problems. I gave you a missing number plus 5 equals 15. Who knows the answer to that? Sharday?
10.
Yep, correct. So, I just put an equation up here with a missing number, and all you did was insert it. And the difference between this and one-step equations is what we do is we use a variable. Does anybody know what a variable is? Ashley?
It's a letter that represents a number.
Exactly. And what kind of letters do we see usually substituted for numbers?
X.
X, what else?
N.
N.
Y.
Y. A.
K. B.
K. As you can see, any letter can be substituted for a number. And that's what we use in one-step equations. When we don't know what the number is, we use a variable to insert into the equation. I like to usually think of like a mnemonic device so I can remember what a variable is. And I just think of X, and I think of a talking X that says, what am I? And that's how I remember what a variable is. So every time I see in an equation X plus 5 equals 15, automatically what I think is, what is this X? So that's what we're going to do today. We're going to figure out what is X. So the first step when we're solving one-step equations, can anybody explain to me, like I see equations and I see expressions. Does anybody know the difference between an equation and an expression? Shannon?
Equations have an equal sign.
Perfect, exactly. Equations have an equal sign. And I'll just put EQ, equal sign, EX, no equal sign. Can you give me an example of an equation?
5 plus 5 equals 10. No.
An equation has to...
I have variables.
Yeah.
Okay, so x plus 5 equals 10.
Looks a little weird. But, Cameron, can you give me an example of an expression?
X plus 5.
Yeah. X plus 5. Okay. So right now, the first step when we're solving one-step equations, well, let me give you a little background first. Me and Talia goes to the restaurant. The restaurant gives us the bill, and the bill is $27. I know that my meal was $5, but I don't know how much Talia's meal was. So we need to figure that out. So we have Talia, my meal, which is $5, plus whatever Talia's meal is, and because we don't know the number, what are we going to insert?
X.
Because X is a what?
Variable.
Exactly. And I know the total was what?
27.
$27. So that's our equation. And I look at X and I'm like, what is X? So the first step when solving one-step equations is we need to isolate the variable. Oh, can I rewrite this? I'm going to just switch these around because it's addition. We can just move it around and it'll all be the same. Because 2 plus 5 is still going to equal 7, whether I say 5 plus 10. So I'm going to change this to X plus $5 equals $27. Okay. So the first step is to isolate the variable. So when you think of isolate, what do you think we need to do? AJ?
Make it by itself.
Make what by itself?
The variable.
The variable. So we need to isolate X. Okay. Does anybody know how we would isolate X?
Get 5 away from X.
Exactly. Get 5 away from X. In our first step, when we isolate the variable, we do that by using inverse operations. Okay, so right now we see an addition. What's the inverse of addition? Subtraction. So we would subtract what? 5. And remember, just like when solving anything with one-step equations, whatever we do to one side, we have to do to the other side. So we minus $5 from this side, and we get what? 0. And then we minus 5 from this side, and what do we get? 22. So right now, I'm left with, oh, I forgot to write down my step. So the first is to isolate the variable, and then we had to use the inverse operation. And so I end up getting x plus 0 equals $22. And just to simplify that, I'm just going to do x equals $22. Are we done with our problem?
No.
You need to put the $22 back into the problem and solve it.
Okay, what's the importance of doing that, Cameron?
You can check your work and make sure your addition and subtraction is correct.
Exactly. Great job. But you always plug in your answer. Equations are set up for you to never get them wrong. Because once you find your variable, all you have to do is to substitute it back into the equation. So what we're going to do now is we have x equals $22. So we're going to put in $22 for x. So as we rewrite our problem, we have x, which is $22, plus $5 equals $27. And we're going to go ahead and add these together. So 22 plus 7 is what, Alex?
30. I'm sorry.
22 plus 5. I'm sorry.
27.
Okay.
I'm sorry, let's use numbers.
I'm sorry. I think I did say 22
Yeah.
plus 7,
Yeah.
but that's still 29.
29. And I said 29 was fine.
But that's okay. That's why we always like to write our work down. And the numbers, like, once you get further in one-step equations, the numbers will get bigger. So feel free to write them out just like you would do, like, old school addition, like in the vertical direction. So 22 plus 5 is 27. So we got 27 on this side, and we're going to go ahead and just move this 27 down. So does that equal each other?
Yes.
So I like to put a nice big check mark and success, because I always like to remind myself that I did a good job. So, as we go through the steps, first, I know the board is a little cluttered, but first we isolate the variable so we can get it all to one side. Then we use the inverse operation, and the inverse operation that we used here was we had addition, so we used what?
Subtraction.
And if we had subtraction, we would use what?
Addition.
If we had division, we would use what?
Multiplication.
If we had multiplication, we would use what?
Division.
Exactly. So we just used the inverse operation, and then since we got our answer, we just went ahead and plugged it back in. So 3 is check work, so that we can never get it wrong. Are there any questions? Okay.